The title screen here. So last one was 86. Now we're on 87. Part 87. And it's video number 160. It's Saturday. Okay, does it all check out? That all checks out. Good. So let's go arrange our dashboard thing here. Let's refresh. Let's also change the go live notification, even though we're off by 1. So we're still working on the camera stuff. So come on. Okay. Okay, so we worked on these like assertions because they weren't quite correct. And now we're just going to try to run this again. And we're going to... What the fuck? Okay, we're going to run this again, and we're going to make sure that... We're going to run this and see if finally we got the correct camera behavior, or if... Oh yeah, that was because we put this in here. We think we got it fixed. We don't know, but let's just see what happens here. And let's just wait for this to roll, and let's see what happens. Okay. So, a moment of truth here. Let's go over here. Let's go P for pattern for a second. Let's go to a pattern that's actually useful. And blows up in our face. So we get blown up in our face here. So the camera span is 256, and the minimum is 256, the maximum is 320. Oh, that's because these are ORs, right? So if any of these... Let's change this. So we just don't know what the hell we're doing, is what that is. So our assert is crashing, but we just didn't write it correctly, right? So we want to make sure that all of these cases are true, and if all the cases are true, we don't want to do anything, right? Otherwise, we have a problem on our hand. Okay, let's try this one more time. Come on, can we get going here? Neither a max nor min match. So we're going to go in here, copy this, and we're just going to see... I believe that's going to come from here. I could be wrong. No? Okay. Okay, so the output span here if it equals the maximum span, we're good. If it equals the minimum span, we're good, right? But if the output span doesn't match either of these, right? So if this, else... Okay, so let's just make a note of this, right? Let's print off what this is. Printf, and input is the camera span, right? And then we have 2 outputs, or we have 1 output, right? We have 3 outputs, inputs. So we have this thing. These are our inputs. This, and this. And then the output is this thing here, right? So and so we should be able to just select all these and print these off. And see what the heck. So it looks like this function is maybe not working how we think it should work. And so if that's the case, we can fix that. That'll be an easy fix. If not, I don't know. We'll look into the camera code because it should take that camera span and it should snip it to either the minimum or maximum, whatever is closest. So if we go over here, P for pattern, and then we try to zoom in again, that is horrible. We need a \n here so we can read that a little bit easier. Okay. Come on, it'd be nice to at least get decent camera code here before we're at next week, you know? Okay, so over here, we're going to go here. We're going to go P for pattern. We're going to find one of these patterns. And now we're going to zoom in. What we got? Camera span, 256. The min span is 256. The max span is 320. Notice that these are equal. The output span, however, is 0. So what the hell? So let's go find this, right? So in here, let's go find where that's coming from, because 0 is definitely not what we want, right? So output span here. So first of all, let's make this a trap value, right? So that's the first thing on the path of getting this figured out. And just say 222 212 000. How about 586 214? And I think that's not big enough. Let me see if that's correct. What's the uint32 max value here? So that's obviously int32 max value. What's our bit rate? Our bit rate looks like it's not too bad. Looks healthy. We haven't dropped any frames. So 586 214 395. Oh no, we don't quite have enough. 586 214 3958. We don't have enough. So 586 214. We're going to say 586 214 for the trap value. One day I'm going to call this number and be like, give me back my phone number. 586 214 3958. Okay, so this output span, are we setting it anywhere? It's right here. The minimum delta and the maximum delta. Okay. The min delta equals the camera span minus the min span. Okay. And the maximum delta is the maximum span minus the camera span. Okay, so we got min delta and max delta. And if the min delta is less... Oh, got ya. So we want to actually subtract that min delta, right? So this camera span right here, we're going to take this camera span. And if the min delta is... Let's say the delta is 0. There is no difference, right? So the minimum delta, we're going to take that camera span and we're going to subtract, right? And if else, if the max delta is less than min delta, and I do see something that I'm doing wrong here, so I know what I'm doing wrong here. So here's the min delta, here's the max delta, and we're taking, if the min delta is less, we minus that. If the max delta is less, we don't minus it, we add it, right? So jump up to subtract down to min Right, so that's what this is happening. And this is going to be add addition up to, right, so we're going to addition up to and then we want to assert right, so if that's correct, then the output span should be equal to the minimum, right? And then over here, if this is true, if this logic works correctly, so it's like, maybe we don't even need to do this, but the output span should be equal to the maximum span, right? So addition up to the maximum span, okay? And then if it's neither, if the delta is not less than, if neither of these if both of these deltas are the same, then it's an arbitrary jump to one or the other, right? So else arbitrary jump to one or the other. So let's go look where this is called from and see if there is information that would tell us if we want to snap up or down, right? So this thing right here is the only function call site. And so here's what we're going to do. We're going to take this and int32 zum int32 zoom direction tiebreaker. So this is going to be a zoom direction tiebreaker here. So that way, when we're doing this, when we're calling this function, we're going to I like having these spans next to each other, so we're going to put the zoom I32 up at the top. I'm going to call this, you know, zoom dir tiebreaker, right? So we're gonna tie break and that means this is going to go up at the top. So zoom I32 at the top, and if we look for where this call site is, it's only here, and then over here, it only exists as a declaration here, right? So this tiebreaker, we want to carry it down to where we have this camera span, and we want to have a tiebreaker, right? So we're going to throw in the tiebreaker right here, right? Right? So this thing now has a tiebreaker that is the direction. And then when we look at this function here, right, we can add that here at the very beginning, right? So this is kind of convoluted, but we want to make it to our exact usages. So int32 zoom I32. And this is zoom direction tiebreaker, right, is what this is. Okay. And then use tiebreaker to select correct camera size. Okay, so if we're even distance to one or the other, what we're going to do to snap to where we need to be is just use that tiebreaker, right? So let's do that. And if we look in how we call this kind of stuff here, right, the zoom I32, it's a negative value when we zoom out, right? So the negative value is going to give us our bigger value, right? So if zoom I32 is less than 0, neg equals an outward zoom, zoom out, bigger rect. Okay? Else, if the zoom int32 is greater than 0, then that is positive equals in, and that's zoom in, smaller rect. Else, bad tiebreaker flag. Okay, so we got a bad okay, so less than 0, greater than 0. Less than 0, you can see from this that negative is zooming out. And to zoom out, we have to set the output span to output span equals the max span, right? We want the bigger value. Otherwise, the output span equals the min span. Okay. So that was a lot of more code than I thought. So that does mean that sometimes we might end up, if we are exactly in the middle at any point in time, like if we do like a manual per pixel zoom and then we use the mouse zoom, there is a rare case that let's make a note of this. 160. Time is 19. And let's do 32. There is a rare case that when we are exactly between the values to snap between, that the camera may appear to do two zooms zooms in, or two zooms out in a row. For now, I don't care about this. It is a rare thing to happen, and doesn't seem like something that will detract from the user. Okay, so there is the possibility that if we're exactly between the min and max values, that and we snap, that that things might appear to like zoom in twice. Possible fix. Swap the snapping choices to cancel out the double zoom. Right, so if we wanted to fix this, what we could do is we could, if we get in a, if we're right in the middle of the minimum and maximum spans, then we might actually just want to flip this, right? So if we're getting a double zoom effect, we'll just make the output span, instead of set it to max, we'll set it to min here, and the output span here, we'll set it to the max here, right? And that'll hopefully cancel out that zooming effect. So let's make a note here that we have stopped our explaining here. So we're on video 160, and the time is 22:23. That'd be nice if we could do that. Yeah, okay. Done explaining. Begin explaining. Right? So I just want to make a note of the timestamps so that you can come back to this if you want to, right? So I'm done explaining that. And I'm ready to give this another run, I think, right? So if we're exactly in the middle, we're just going to arbitrarily pick based on the direction we're going. So if we're zooming out, we're going negative, then we want to make the rectangle bigger, right? Bigger. Bigger equals zoom out. And smaller equals zoom in, right? So I know I'm kind of like beating that into the ground, but that is the way it is. Okay, so let's hope that we're not completely crazy and that all this code we're writing actually gets us somewhere, because I'm just like, whoa, like really? Like, I feel like we're making this way too hard, harder than it should be. But you know what? I mean, the thing that's making it a little bit harder is because we actually still want to support that pixel per pixel zoom with the shortcuts, but when we use the mouse, we just want it to snap to those increments, and that's kind of the thing that's making things kind of odd. Okay, so now, no dice. No apparent zoom at all. So if we use our zoom in the, I think it's R and V will zoom in. Oh no, V to zoom down, right? Okay, my math is off. Let's go look at that, because maybe that will save us. But I don't know. I am sick of this right now. This should be span new, and it's saying that my math is off, right? So I guess the first thing we want to know is, well, what's the math, right? So printf we got span check x, we got span check y. And then we actually have what the values are, right? So X's then Y's, zeros and ones. And then after that, we also want to look at this span new, right? Because span new is what we're comparing it to. Okay. And this is quite the ridiculous amount of stuff. So printf okay. Okay. I guess we'll give that a run and see if we can kind of figure this out. I am kind of like, I don't want to look at this. I just want this to be done. But yeah, let's just take a look at this and see if maybe we can figure out what's going on. And yeah. Okay. So right now, zooming does not work at all. So we can zoom in with the keyboard manually, right? And then we can try to do some zoomings here. Okay. And my math is off? Yeah. And what do we got here? We got 54 and 201, 54 and 201. And the span is 160, right? Okay, 201 minus 54, what do we got? Span check, where's span check coming from? And here's the new span. Well, first of all, let's make sure this is correct. Also assert that the span old greater than 0. Okay. Then over here we might as well say, like, you know, over here, this new and this dex should be coming from here. So we can also do an assert here and say assert that, okay. And we can also assert san new greater than 0, and san new less than or equal to 512, right? Because we know we're going about only that high right now. And assert that san dex is greater than 0, and right now this span should be... So this is the 26th, so this should be 25th, right? This is number 26 right here. I got 27, so this is the 26th. So it should be less than or equal to 25. Okay, so let's make a note. At vid IID, 0160, time is 0032, and let's say 13. So we're going to explain the asserts right now for the camera, for our recording camera, not for the camera code we're working on. So these asserts here, so this span and the index, this index is actually index accessor into this data here, right? So the span that we get out should actually be able to be retrieved using this index, which is kind of like wonky, but that's the way you do it, so we can assert that that's correct. Also, currently our span should be greater than 0 and less than 512, because if we look here, we see 512 is the maximum, and then actually it's 2, because 0 we should never hit, right? So actually that needs to be between 2 and greater than or equal to 2, and less than or equal to 512. And then this index can be greater than or equal to 0. So let's look at this. The 0th would be 512, so that's valid. And then the 25th is also a valid index. So let's go back here. So this is greater than or equal to 0, and then less than or equal to 25. So this 0 to 25 is coming from the 0th slot and the 25th slot. And this is a null terminator. It's not a piece of valid data. Okay. So we've added some more asserts just to sanity check what's going on and hopefully maybe find some more problems in the code. Because I don't know. I'm kind of like, I hope I can get this, figure out what's going on, but we've written a whole bunch of like wonky code all over the place. Integer expression, signed error. Okay, so the assert we didn't quite write correctly. So over here, over here, this span old is the int32. That's an int32 cast. The width and height, though, are u32s. So actually what we want to do is a u32 comparison right here. A u32 comparison. And we're just going to do it this way so that we have... if we cast back and forth like this, I think we might catch more problems. I don't know. Doesn't really matter. Assert the old span is greater than 0. I don't know if that's always true. Whatever, we'll find it out, alright? This is the point of writing all these asserts, so we can figure out what's going wrong. And why is camera resizing so difficult? Like, it's like, this is what we're talking about polish, right? Polish takes a lot of time, right? I mean, that's why to make like a quick little game without any polish, that part's really quick, but then, you know, what is it? 80-20 rule, so your code is probably going to be 80% polish, right? Assertion failed, 1585 and PAINT5D. So 1585 is one of these guys, huh? Well, first of all, this is supposed to be san old, first of all. This would be the old span. Right, so san old equals the width and height, right? And the width should equal the height, right? So... while we're here, let's just... These are the things that we want to assert are true, right? So I know that we probably don't need this, but since we're here, since we're asserting the crap out of this, we want to assert that all these are true, right? So 1 and, right, all these things need to be true. And if that's the case, okay. Otherwise, error something 2021-02-27 at 8:02 p.m. Okay, so let's give that a shot. And we just wrote the assert wrong, so we might not actually even have to look at that. But the more things, unexpected identifier, something, is a U32 a bad identifier? Is our bracket balancing somewhat off? Our bracket balancing is off, right? Yeah, bracket balancing is off, so we did this cast, and then we wrapped it. And then over here, okay, I see. So, I mean... Okay, so zoom in, zoom out, nothing. Let's do a V key to actually manually zoom in. And then when we try to do it, use that zoom key, something's going wrong here. So, why? The span new is this. The span check is 152, but what the hell are we comparing it to, right? So first of all, this is a horrible message. Because I can't actually click it and find where my math is off. So let's go find it in here. Let's make a new error message that I can just double click and find it easily. And then let's go over here. Let's put this on the other monitor because I just want to see the console output while I'm kind of working on this code, right? So why the heck is my bash script? There's just a random bash script open, not doing anything. Okay, so let's go look for this code. Okay, and the span new is 160, but the span check is 152 by 152, right? So, we were supposed to apply the snapped well, hold on, are these spans possibly... No, these seem signed. dx, dy, int32, minus this, we get the snapped int32s. int32 this, int32 the deltas. So what's up with this? (203 minus 52). 203 minus 52 plus 1. What do we get? We get 152. And the span that we're expecting is 160. So we're taking this delta, we divide the delta in 2. We make sure that this span is, before we divide it by 2, we make sure that is equal to 0. We make sure that it's divisible by 2 before we do that. So should be pretty basic. Well, first of all, where's this old span coming from? Is it actually, do we actually retrieve it? Okay, so we did retrieve it over here. And well, span old, is that a int? It's an int. How about span new? Is span new an int? Mm-hmm. Mm-hmm. Yeah. We should be able to apply the delta to get where we're going. But the nearest thing we're snapping to, we don't really know if it's above or below, do we? We don't really know that, do we? So yeah, I don't think this is correct. I don't think we need to know which direction we're zooming here. So the direction of, we're trying to snap. Right? So this thing we have, let's change this to old, add to new. And we're going to get rid of these asserts here. Okay. We're still expecting the division, right? But old add to new here. To go to the old to the new, we have to take the new minus the old. Right? So if the old is, so let's say we're going 1 to 2, right? So the old is 1, the new is 2, right? So 2 minus 1 gives us a 1. And so we can take that 1 and we can add it to the old to get the 2, right? So this is old add to new. Vector. It's a vector. Old. Right, so vector old to new is kind of how we're doing it, right? And I don't actually think we need this. So then we need so I don't think the snap needs to know about the zooming direction. So I don't think the snap needs to know about the zooming direction. I think I was wrong on that. So let's throw this in here and see if maybe we get some better results. Right, so the snapped values here. To get there, we want to take the old, right? So these are the old values, right? And but that also means that go from old to new here, we need to not go this way, right? So we're trying to so pretend that the old and the new is bigger, right? We're trying to add to get into that direction, right? So that means that this should be an addition, right? We want to do whatever makes things bigger, right? So we want to, actually no, this would make it bigger, right? Because, whatever, God, that is kind of weird. So the default behavior, let's say that these are positives, right? So old is 1, new is like, 100, and this is, new is 100, and this is 100, this is 1, and this is 100. So the new is 101, the old is 1. So this is 1, this is 101. And so new 101 minus 1 gets us 100, so we have to add 100 to this to get to the new, right? Okay. And so then here, we're adding half of that 100 to grow this side, and then we're subtracting half of that 100 here to grow the other side, right? Okay, yeah, that makes sense to me. So let's try this, right, and hope that maybe we got like a better kind of formula here. But in this section, right, this section is apply camera snap, so we don't really need to know what direction we're moving in as far as I'm concerned, as far as I know. So let's try this and see if maybe we have better results. So P for pattern. I'm going to guess that no, this is not going to work out for me. So interestingly, we're not crashing anymore, so that assert isn't failing us, so that's cool. We're getting the snap. Seems like maybe we're getting the snap, but we're not getting the next part, right? So we get the snap, right? We get the snap. And then we want to apply the final state. So add to next span and the span new, right? So when I go from span new to the next span, right? Maybe we got this wrong. Maybe we're wrong here. You know, we might as well just try it, right? Like, maybe we don't know what we're doing, so maybe we just want to just try something, right, and see what happens. So I don't think that's it. I think we had that sign correct. But maybe we don't know what we're doing, right? And then if we got that working, then the question will be like, okay, it works, but why does it work, right? So then we still have another problem on our hand, don't we? So this is... Okay. So it doesn't look like it works. So now the next question is, I don't know, maybe want to log this, right? Maybe want to log it? I don't know. I'm kind of at a loss here. Jeez, where the heck are we? Okay. So, I don't know. Let's just try that and see if maybe... See if we get some type of value that kind of surprises the heck out of us, or what we get here. I don't know, though. I'm actually kind of like... this log is going to require a void pointer cast, isn't it? And yeah, this logging function, I like having one logging function like this, but holy crap, does it make it really annoying to get this working. Because we have to cast this to a, let's cast it to int pointer since it's signed, and then we have to cast it to a void pointer. And then if we finally do all that correctly, we can actually see what we have. So it's like, that is kind of like, why? I know why. It's because I have very strict settings on my compilation here. That's why. But holy crap, does it make it hard to get this kind of basic logging behavior working. So now we need an int pointer thing. So we need to go down here, because I don't think we have an int pointer declared for this section. So we got to go all the way down here and say, yeah, we got int32. We got, so if we want an int pointer, might make sense here. So define int pointer, right? So it's the int that's the size of a pointer, right? So undef IP for int pointer. And then we'll go back up to this section, up to the top of this section. And this is the one we want int pointer, right? So define int pointer. So int max type. Align that nicely. 02. Then we're going to move these up, right? So we're going to move these up. We're going to make this the 8th. And hopefully we can get that logging working. And then, I don't know, man. I hate this right now. So let's take a look. Okay, try to zoom in. We got new to next is 0 here. Okay, what if we zoom in So it looks like every time we do this, new to next is like, it's giving us a 0. So what, WTF, man. So ATO next, right? So let's go find out where that's coming from, right? So this thing is so if san new right, if these equal each other, we have some problems. So this could be okay. There could be some cases in which this is okay, right? So one case in which this is okay is if we have a zoom, right? We have a zoom in here. And so this in32 zoom, negative is zooming out, right? So fine. Greater than 0, we're zooming in. And let's say we're already at 2, right? Fine. Can't zoom in further. Okay. Okay, otherwise we have a problem, and we also might want to know what the zoom value is. Okay. Let's give this a shot. I'm tired of this. But let's just try to give it a shot and see if maybe... Okay, so... So right in here, we're air checking the next span, right? And we found a problem. So let's actually try to make this like a little category here, a little section. And let's also change that to OK. Right, it's OK because we can't. So let's just make a note of this, right? So let's make a note of what we're trying to do here. So at vid IID, it is 160, and the time is 1:06:32. The new camera rectangle size, san new, should be different than whatever camera rectangle size we snapped. Oh, that's weird. The final So first of all, the naming convention for these variables is kind of like bonkers. And that's also what's making this hard, right? So the final camera rectangle is san next. And that should be different from whatever camera rectangle we snap to, which is san new, right? So we san new and san next, they shouldn't be the same. And if they're the same, then we have a problem. And we are seeing a problem. Where span new and span next are at 256. Now, actually, that I think of this, we should actually never get to, we should actually have this, 256 looks kind of suspect because 256 is actually something that we could, that we might want to be snapped to. Anyways, let's see what we got here. Excellent. Yeah, suspect. Yes, yes. So 256 is suspect because we added this 512 just for funsies, and maybe we shouldn't have because we shouldn't. The camera for this editor should never go above 256 for 256. So the camera selection rectangle should never be bigger than 256 by 256 because this is the zoomed all the way out for the current editor, right? Now different editors may need a camera selection region that is bigger to be zoomed all the way out, but this is the maximum selection rectangle size for the camera. And so if we're at 256 by 256, I don't think we have any code that says to stop it from going to the next place, going up further, right? So we need some type of truncation. And so actually, this span new, we said less than 0 and equals 512. Actually, that's not true. So, if we're zooming out and the camera size is already 256, then we've hit the limit, right? So, 256 equals PAINT5D camera limit. Okay, so first of all, the assertion is just wrong. The assertion was wrong. Yes, hey, how's it going? So I'm trying to get a little bit more code done. I hate this. Yeah, so camera, I have... This should not be this hard. Like, I think... Right, I just wanna snap to, right? I just wanna be able to incrementally zoom by single pixels when I use the keyboard shortcuts. But then when I use the mouse shortcuts, I want to snap to basically one of the nearest ones of these. But I don't want to snap to one of the nearest ones of these. So if I'm between, say I'm between 96 and 80, then I want to snap to whatever one of these is closest. And then I want to jump down to either here, or I want to jump up to here, right? So I want to snap to either here or here, and then jump up, snap here to here, or jump down, right? Depending on if I'm zooming in or out. And so I want the ability to zoom at a incremental zoom at a very... I want the fine-grained zoom as well as the snapped coarse grain zoom is kind of what I'm trying here, and I don't know what I'm doing wrong. And so we're hoping that eventually all these asserts will help figure out what we're doing wrong here. So I'm noticing that I'm getting the snapping behavior, but then I'm not getting the jumping to the next size. So if we go over here, and we put a pattern in here, right? And if we try to zoom in, the zoom key... well, that just blew up on me. So the zoom is positive. Positive means a zoom in. And if we're zooming in, then we want to go from 256 to like 244 or something, right? And if we're zooming in, we are already at 256 by 256, I know, because that's how the engine starts. And it's saying that the span new, the span we snap to is correct. That's correct. But the next span is incorrect. That's not the correct span. So we know that for this code here, right? This is our error message, that the problem is with this next span. So why don't we highlight, let's clear out our token highlighting, and let's look for next span and see where that is being set, right? So so this next dex here, right? So we're just gonna say, we're gonna make a very specific case for this. We're just gonna error check for that specific case. So if next dex, well, where is next span, though? Or are they moving up or down? So we're going to make a very specific condition here. Do we have a debug flag for this? Let's go look at this for a second. PAINT5D data. Do we have PAINT5D data here? Let's go open up PAINT5D data for a second. Because I feel like we might have a macro for this. Debug variables. Let's just use this. How long until you get Twitch affiliated or whatever it's called? I will answer that just in a second. I'm gonna put this here. And we're gonna set this to 1 and hope that we don't have too many problems. Miscellaneous inline test, right? We already have a debug variable for this, right? So we can make a debug because we don't know what's going on, but we know a very specific failure case. So we're gonna write code in here for that very specific failure case, and then we're gonna put some stuff here. Yeah, so like subs and bits and stuff. So first of all, I don't really know how Twitch works very well. So like subs and bits and like I'm like I don't know what the heck that is. Like I know there's like I've been given subscriptions to some people I watch and I'm like I don't even know what good this is. Like why am I being given this? I don't even know how to use this. And I mean we can take a look at that. I mean let's go take a look, right? So you're asking, let's go take a look at here. I bet we can find out. So I believe that one of the things is that I need more average viewers. So let's just take a look around while you're here. Let's just see. Oh, is that gonna erase my chat? Ah, man. Oh well. So I know what you asked, so let's not worry about it. It's in my something stream summary, path to affiliate. So let's go look at that. Can we click this? Can we get more things? So you see 62 out of 50. 30-day performance. Oh, okay, here we go. So here we have the stats, right? So streaming, I'm obviously doing plenty of that, right? So I have 170 out of 8. Stream on 7 different days, 27 out of 7. Average of 3 viewers. So we got 1.25 out of 3, right? So what I'm thinking is that the engine design is just going to have to get more interesting before I get like more average viewers. Right, because a lot of this is just boring code, and I am doing a lot of it, right? So I will need... So I could like try to... Like I know some people try to be like, oh, I'm only going to stream when I'm doing the interesting stuff because I want, I want to get that average view count up. But the thing is that the primary purpose of Twitch right now is to... Hold on. Let's go back to the chat. So I can't... If whatever you typed, I probably can't see it in here because it got erased from the logs because I don't know what I'm doing. So if I go in here, everything's kind of removed, right? So if you typed anything... Oh, hey, okay. We've seen... No, I mean, I've been streaming on and off for... like 3 years. But I only recently got serious to where I started, like, doing stuff, like, all the time. I used to just program and not, like, talk about what I was doing. And I was working on a lot of different prototypes. And I finally after messing around and making lots of different prototypes, I finally figured out... I finally kind of settled on... I'm absolutely certain I'm using C code, right? And I finally settled on... the exact specifications for the engine design. So there were a whole bunch of things that I wasn't certain about, and I was making all these prototypes, and I wasn't talking during the streams. I was just using the streams to help log my time. And then I'm like, you know, maybe I should explain what I'm doing, because I can use this as documentation, right? I can use these streams as documentation to help me know what the heck I was thinking when I built this code, right? Because I plan on working on this code base for like, ideally I would like to just keep on working on this code base till I'm dead, right? So I don't know how long that'll be. Hopefully a decent amount of time. I don't want to think about that, but hopefully a decent amount of time. Right? Like, I want a code base that's going to be around for like 10 plus years, right? So I want to go the long game. So I'm not going to try to not stream just because I'm not getting viewers. I'm going to just keep on hacking away at this for years and years and years, and then eventually it's just going to get more and more and more impressive, and then more people are going to hop on and view what I'm doing. Right? So if you look at somebody like Jonathan Blow, who already has made like an awesome game, more people are watching him because you know he's the real deal. So same thing with me. Like, more people are going to watch me as I have more impressive things to show off, right? So the level of impressiveness will slowly grow over time as I keep on adding on feature after feature. And then eventually I'll just have something awesome, and I'll have a lot of viewers, right? So 27 days, well, let's think about that. Well, that's like 27 out of whatever, but we could actually go in and find, how can we find when I started this? So, well, first of all, this is the 160th video, right? And sometimes I do more than one video in a day. So I've been doing this seriously for no more than 160 days. So I know that for certain. The other thing we could probably do is, if I look at my video, this kind of started when this is kind of convoluted path, right? Because I started doing some shader code to try to make a renderer to render patent drawings for the mechanical patents I was working on. And then the shader toy code I was writing got way out of control, and it's like, oh crap, we can't do everything we want to do in shader toy. We should just do it in a C project. And then I'm like, okay, well, if I'm going to do a C project, oh crap, I need this whole foundation to get shader code working. And then I'm like, you know what, well, if I need this whole foundation, let's just start working on the engine that I wanted to work on in the first place, and then set up the engine so that there's a nice structure in which I could shove a patent renderer shader into the engine sometime in the future. But so I keep on going back and forth between, I keep on going back and forth between, no problem, I thought it was going to get deleted too. I thought this log was going to get deleted as well. I didn't think that this was going to stay here. But yeah, I keep on going back and forth between patents, like mechanical patents, and physical designs, physical things at the machine shop that I want to sell for money, and then code. I don't really understand patenting stuff either. That's why I had a patent lawyer, because holy crap, that stuff is complicated. But I was like, man, I really want to patent my package design, but I don't want to spend more thousands of dollars on another patent with a patent lawyer, so let me just try to file my own patent, right? That's what I was doing. And I'm like, man, this stuff is complicated and I need correct drawings, so I need some way to take blueprints and render them in a very specific way for patent drawings. And I'm like, hey, I could make shader code to do that, right? All my designs are very grid-based, so I could create a very specialized voxel renderer for this, and I could make the blueprints. And I'm like, alright, let's try that. And so I started writing some crazy shader code. So if we go to like shader toy, I can show you. So let's like sign in for a second. If shader toy doesn't crash me, like I like shader toy, but I really hate this bullshit here. Right, each one of these is a different OpenGL, a different WebGL context, and holy crap, it always crashes when I go to it. Like, please find a way to make an animated GIF of this stuff rather than starting up an entire shader context, right? Because it's too much. It's always been too much no matter what computer I've used. It's always does that. It's like, man, you must have to have a really high-end machine to get this working. Anyways, I'm going to log in here. I don't know if it's a simple... I gotta go look for this for a second. Shader toy pass. What is my password? Okay, my password. My password is my 8th grade password. Am I going to tell you what my password was in 8th grade? Nope, I'm not going to tell you. But sometimes when I write down my password, right, you're not supposed to write down your passwords. So I just write down like a hint that tells me exactly what it is. So, yeah. Okay, so we're in here. Holy crap, what are all these notifications? Did I do something wrong? That gives me anxiety. Yeah, I got like 62 little things. So let's take a look at this one. I think this was the last one that actually got somewhere decent. So a lot of people think of voxels as 3D pixels, but I don't. I think that voxels, to do a I actually think the proper way to do a voxel is a three-dimensional tile, right? Or a three-dimensional tile, right? So tiles are made of pixels. So each voxel is just a tile that has, instead of an XY axis, it has X, Y, and Z. So what you're seeing here is, you know how usually when you when you clip geometry in 3D, you usually clip through the polygon, right? Well, the way I rendered my voxels, I made it so that if you clip through the geometry of a voxel, you see the individual three-dimensional pixels of each voxel. So each one of these cubes you're seeing is actually one voxel, and then I shaded it so that you can see the individual three-dimensional pixels of each voxel. So, you know, when I read up on voxels, people were just saying, "Oh, 3D pixels," but I think that's actually wrong. I think a voxel should actually be a three-dimensional tile, right? Because when you're working on a game engine, like a 2D game engine, you don't make a map in pixels. You don't set pixels to make your map. You set tiles to make your map, right? And tiles are just clusters of pixels, right? Like a tile could be 32 by 32 pixels, 16 by 16, 64 by 64, something like that, right? So if we're going to paint a world in voxels, to extend the analogy of a tile map into 3D, that would mean the voxels should be tiles, not pixels. But all the documentation I can see on voxels says, oh, it's a three-dimensional pixel, and I disagree. I disagree, and maybe it's just that I don't know enough, and I'm an idiot, and I'm just being like, screw you, I'm doing it my way. But that just seems like the logical, right? When you try to take something from 2D to 3D, you want to maintain the abstraction and just add another axis to it, right? So this seems like the correct way to do it as far as I'm concerned. Oh, and if you want to take a look at this, I can actually put this on put this in the chat for you. Is this over here? Yeah, I can throw this into the chat for you. Yeah, it's a cross section. Yep. So you're seeing the cross sections of the voxels. Because I'm thinking that if we're actually going to render volumetrically, right? So voxels are supposed to be this volumetric way of rendering. If we're going to do an actual proper voxel, we should be able to clip into the geometry of the level, and instead of getting this kind of like polygon voidness BS, you know how like you clip into the geometry of a 3D video game that has polygons, and it kind of breaks the immersion a bit because it's like, oh, there's just empty space inside of these models, right? Like all the 3D models are just empty space. They're just empty husks, right? So if we want to not have that, and we want to be truly volumetric, we should be able to have a camera that when the camera intersects the geometry, we should never see empty husks. We should just see cross-sections, right? And if we're not actually seeing cross-sections, then we're not actually doing things volumetrically. or at least that is my opinion on the matter. So voxels obviously are three-dimensional, and right now I'm actually working on a 2D engine. Though I am kind of like hoping that this tech will create some awesome data sets that will allow me to make 3D voxels. Like I'm hoping this engine, even though this engine is 2D, I'm gonna hope that it will actually give me a strong foundation to build off of the engine and pipe this engine's data into like a 3D voxel engine. Like I can abstract the data sets into 3D in the future. But right now everything is 2D. Yeah, I think there's an idea of voxels being used to store images in 3D, in which case a voxel is like a pixel. But yeah, voxels represent units of 3D space, really, not to be the most atomic item. Yeah, exactly. I don't. You're correct with the atomicness, right? Like I don't think the voxel should be the most atomic item. I think it should be these subpixels of the voxel. And I've done some math to figure out how I can make a nice voxel rendering engine that will be an extension of the current engine tech I'm working on. But honestly, with the rate I'm going, we're talking like 10 years down the road before I get to 3D, right? So right now, for the foreseeable future, 2D, and maybe 10 years from now, I'll have a nice foundation of an engine where I can start abstracting stuff into 3D. And I've kept notes about how I want to do voxels, because once we start zooming in at extreme levels, we have to make sure that we have enough bits, right? We have enough precision to zoom in as far as we want to zoom in. The coordinate system that I need to use for the voxels that I want to do is going to select very specific ranges of values, so that we don't get any integer overflow when zooming into the deepest depth that I would like to zoom into. And that also means that the level has to be a very specific set size, because the larger your level, the more addressing space you need, right? And so if you have a very large level, you can't zoom in as far, right? Because you're using a lot of that addressing space in your integers to go to different coordinates. And if you've already used it to go to different coordinates, you can't use some of those bits you won't be able to use to zoom in. Now that's kind of like that might not make sense, but you have to realize that the way I'm zooming in and out of things is by positioning I'm just taking what I do in 2D and turning it into 3D. So for me to zoom in and out, I just take a rectangle in 3D space and I make it bigger or smaller, right? So I have like a camera rectangle that we project pixels onto, right? So we do like I do a like ray tracing kind of algorithm, but I use ray marching. So I do voxels and I do ray marching, and I just map onto a rectangle that's floating in the world to get to the screen. So there's this rectangle, and it's a two-dimensional rectangle floating in three-dimensional space, and we project pixels from the world onto that rectangle, and that rectangle, whatever pixels end up on that rectangle are mapped directly to the screen. So that's kind of how that works. And I see somebody else kind of stepped in here, so I'll throw that shader in there so you know what we're talking about. But I am kind of ranting because I'm actually trying to figure out why my zooming code is not working correctly. And also, it's 9:01, so there's two things I need to do really quick. Actually, I'm going to throw my demos in here in case since I do see two viewers. I'm going to throw in my technical demos in case somebody new wants to see what I'm up to. And then we're going to get to this, right? We're going to get to this error finish this error check code. Okay, so we're going to now, how does that work? Does that I actually don't know how this works. Because this is compile time, right? So I don't know if that means that since this is inside here, that this error gets triggered at compile time, or if that actually has to happen at runtime. Actually, let's just see. We'll find out really quick right now. Right? Because if we get this error, we'll know. But I just put like a compile time error. Okay, yeah. So it is compile time. The logic here has no bearings on this compile time error. This is a compile time scope here, so that does have bearing on whether or not this will get triggered. Anyways, I'm just going to put this here as a reminder, right, so that I don't leave this code unfinished. And I need to, right now, at the very least, go take my drugs. And then if I look at my push-up, hopefully, I start losing weight, right? Though we might eventually get to the point where I'm just gonna have to do like some intermittent fasting or whatnot. Like the idea is to like, I know this is kind of a weird analogy, but keep a predator mindset. I know people sometimes will think of predator as like a pejorative, like, you know, for example, sexual predator, right? But I think predator as like top of the food chain, right? So if you're a lion or a tiger, you aren't going on a diet, right? You're eating whatever you want to eat, doing whatever the hell you want to do, right? So for me, I think that I want to keep that predator mindset. Or some people, I guess, the more positive way people say that is predator equals growth mindset, right? So a lot of people will say as a growth mindset, right? So the idea is that you're not going to limit your food intake, or you're not going to cut back on your spending, right? You're not going to cut back on your spending. You're going to figure out how to make more money, right? You're not going to cut back on your eating. You're going to figure out how to burn those calories, right? So I'm trying to keep that kind of mentality, because I think that what I find sometimes is that if you start fasting, your whole your brain or something happens to where you become lethargic, right? So your metabolism will try to scale back even further. And guess what? Guess what is linked to your metabolism? How about your metabolism is almost like your CPU clock cycle, right? So if we start scaling back our metabolism, then we may find that we become more mentally lethargic, right? So I'm not a doctor, so I don't take this as medical advice. Don't sue me. But these are my hypotheses, and, somebody changed my mind. I'm willing to listen to somebody if they have evidence to the contrary. Oh, God. Okay. So anyways, I have to go at least take my drugs and at least do 20 more push-ups. 20 more push-ups will take 5 minutes. Going upstairs and downstairs takes like 5 minutes, 8 minutes if I'm taking my sweet time. So 8 and 5, 13. I would like to maybe try to cook some food, or at least get a snack. So I'm going to say 16 minutes is what I'm going to say. 16 minutes, I'll be back, and I'll see you if I see you. If not, it was good seeing you here. But But I cooked some Brussels sprouts and I put some meat in the oven for an hour. So probably what I'll do is once it's time to eat, I'll probably do my push-ups and stop the stream and come back at another day. But yeah, so for this test here, if we are zooming in, if the zoom we snapped to is 256, and we are zooming in, then make sure the next So this is the specific case of what's going on here, right? So this is a specific case, hence why it's in a debug section. And let's make a note. This is video number 160, and the time here is 1 hour, 58 minutes, and about 42 seconds because we want to be cool, right? So, okay, so right here, if the next, if 256 equals next span, right, and we're zooming in, right? So a positive value means we're zooming in, which means that the rectangle should be getting smaller, right? And maybe we got this wrong, right? Maybe we got this wrong, right? Mm-hmm. Okay. And if this is the case, expecting more. So we're definitely not, we're expecting it to change, right? We're expecting that this is the span of the camera that we're snapping to. We are zooming in, and so we expect this to be, if we really want to look here, we can know exactly what it should be at this moment. 256 should go down to 224, right? Now this could change in the future, but we know that as it currently stands, we should be ending with something like 254 or something. I expected less. Okay, so hopefully the debug flag that we just turned on doesn't end up crashing in some other place, because that would suck. But yeah, let's see if we can get to this, and then we can see, let's just print off some stuff, right? So print off san new. And then the next, right? So the span next. And let's also print off this zoom thing, right? Let's just print off all the things that we probably want to take a look at. And let's give that a shot. See if we can find anything going on here, or what's up with this, you know? Because I honestly have no clue right now. But the cool thing is that at the very start of this, we have already found the condition that's happening when we try to use the mouse wheel, right? We try to use the mouse wheel, and we want to zoom in, right? So, zoom in. What do we get here? So we're zooming in, so 1 is for a zoom in, because it's positive. and I scrolled the mouse wheel. I brought the mouse wheel towards me, right? I did like a come here motion with my finger, and that gets a positive zoom value. And we see that 256 and 256, I expected less. That is true. And so now we got to figure out, okay, so we found one of the cruxes of what's going wrong here. And now it's time to just figure out where the heck that's happening. So this next span, this next dex, so where does this spandex come from? So knowing what this index is could be important, right? So is it different, right? Is it different than the so we have the original index, and then we have the sandex. We have nextdex, right? So nextdex is being used in here. Okay, so we're expecting that these two are not going to be equal. If they're equal, that is somewhat of a problem. So let's go look at that for a second, because I'm going to guess they are equal, and that's part of the problem. Or I think that's my guess, I don't know. And that they're pointing at the same thing, right? They're pointing at the same thing, hence why we have 256 for both of them. That is my assumption. I could be wrong. Let's go figure that out. Come on, please. Can we just be done with this? Can we get some nice scrolling action? So sandex and nextdex are 5 and 4. Okay, interesting. So let's go look at that. 0, 1, 2, 3, 4, 5. And this is 4. Where's next span getting here? Okay, so what we're gonna do here. So what I'm seeing is these don't look right, but what does look right is these indexes, right? So oh, holy crap. Oh god. Oh god, I'm being, oh no. Oh my god, I'm an idiot. C will let you do stupid things. And that's fine. Right here is the problem. This is wrong. Yeah. So we're saying this, and we back up 1, right? So equals this minus 1, right? So a plus plus actually affects the variable, right? and then we do assignment, and that is wrong. And because it's a post increment, the values aren't identical. So we can't even catch the problem because the values aren't even identical. But yeah, so right, and then this we can all still make like this, right? So this still has to affect itself. That's fine. It's just that those variables were not correct. Okay, so let's give this another shot. Maybe if we're lucky. If we're lucky, maybe that was the only stupid thing we did, and maybe like everything else will work, and maybe like all of our basic logic was all nice and correct, and we just did some stupid syntactical thing, and everything's gonna be fine, and blah blah blah. Let's find out. So let's just do 1, go over to here. Let's do P for pattern. Let's go in here, and let's try to zoom. Nice, nice. So you see this is much punchier, right? So if we want to zoom in here, right, we can zoom in a lot faster, right? And we're down here. We're going to do like this kind of like 1 pixel zoom for a little bit. So if we're all the way here, actually that looks like a 2 pixel zoom. That actually might be a little bit too punchy, right? Because I'm expecting here, and it's actually taking 2 on each side. Okay, so that's close to what I want, but I think it's just a slightly... It's slightly too punchy. So this is 4x4, right? So at 4x4, we can go... go look at the table here. At a 4x4, we're supposed to go up 2. Oh, and that's per each side. So it seems a little bit... It seems a little bit too punchy. Like, it's close to what I want, but it seems just a little bit too punchy. So... yeah. It seems a little bit too punchy, so I don't know why that is. We got this new span, we got the old span, and the delta x, right, we take the spans and we divide by 2. Well, hold on, let's make a little diagram here, right? So if we have, so let's start with the 2x2, right? So we have the 2x2, and we want to move up 2. The next span is a 4, right? So the next span is a 4. So we're expecting to be able to okay, so we're expecting to be able to go from here to 2x2 and then a 4x4, right? And so to get to this, this is 2. Okay, then over here is 4. And if we want to take the delta, right? Delta equals 4 minus 2 equals 2, right? 4 minus 2 equals 2, right? And then to grow here, right, we add 1 here, we add 1 here. That gives us 4, right? So that seems all correct and whatnot, but that's not what I'm seeing. I'm seeing what looks to be like a more extreme kind of zoom than what I would expect. So my thought is that we're already exactly... Here's what I think. We're already at... So between 4 and 2, we got to snap to it, right? So I think what's happening is it's snapping to here. Then the next thing it would do is it would go up. Yeah, that just seems not... That seems too extreme. It seems like we're really close, but something about the zoom seems a little bit too punchy. Like, it's great that it's punchy, and it's definitely close to what I want, but I don't think it's actually behaving how I expect. So in here, for example, this is a 2x2, and then all of a sudden, we're adding 1, 2, 1, 2. We're adding 2 on each side, right? So whatever we're adding here is wrong, I think. So whatever we think we're doing with this is not right. So old add to new, and we're doing this, right? We're dividing it by 2 first. Right, because we have the span new and the span old, right? We divide by 2, and this is effectively a multiplication by 2, right? Oh, actually, if this is not equal to span new, it's gonna error out on us. And then we got some error checks that are passing. So we're logging this. So let's log some more of this. Let's log next SAN, right? Next SAN is the final span. So let's log that for a second and see what's going on there, right? And see, maybe if we can we glean some type of information on this? But we're getting close. We're getting close to where it's like, I'm almost done to where I have this zooming capability to my liking. But it just seems like it's off by 1 step. Okay, so here, next span is 2, right? So next span is 2 because it's 2 by 2. And here it says the next span is 4. Oh, yeah, that's right. Okay, got it. So this zoom here, if we use a 1, that's going to be a 2, right? That's going to do it twice. So this actually needs to be divided by 2 as well. So there's a whole bunch of transformations here, but it needs to be divided by 2. Because this is going to be applied to, it's going to be applied to, if it's a 1, it gets applied on each side. So, so before I say that's correct, before I make a timestamp for that, let's make sure that's what it actually is supposed to be. So P for, okay, this P for pattern, go to pattern we like. Okay, now that's better, right? So this is less extreme. Let's see, we have this 1 pixel zoom here. So this is 2 by 2. So this is 2 by 2. This is 4 by 4. 6 and 6. 7, 8. 12. And then it gets a little bit faster and faster as we go out, right? So the next thing, though, is that it looks like it might be stopping at 320. So let's go to the last pattern here. I mean, it looks like the pattern is... Actually, that seems correct, so... Oh, you know what it is? It's, we have to flush the console. Actually, let's go... Yeah, that doesn't look bad. That looks correct. It looks correct now, but the log sometimes looks slightly erroneous. It looks like off by 1. So... we have manual zoom, right? So we have the ability to manually zoom in and out if we so choose, right? So we can zoom all the way in here and say, okay, that looks correct, this is correct. And then we can zoom all the way out and we see this says 320, right? But I don't think that's correct because if we do R, so R and V, right, are nice smooth zooms, right? Nice smooth one at a time zooms. And this is zooming out, so the R key is zooming out. So if we zoom out here, it says 320. I'm not getting anything more. It's just saying, you know, it says 320, but I think it's like lying to me. I think it's lying its ass off. So let's really quick just go find the log function. So AAC 2020 PAINT5D log and see if info any. Do we forget to flush the standard output? I don't think we did. Alright, so let's go backwards direction and find the first instance. Oh boy, this is a big thing. Holy crap. Really? Oh, we're not wrapping around. Stop wrapping around. Okay, so, nope, we're flushing right here. Am I not looking at the value that I think I'm looking at? So that's a possibility. So this thing, I'm expecting this to be 256, and I'm getting the 320, right? And then down here, I'm expecting 2, that works. What's 320 plus 64? $384. Yeah, I don't know why that's logging how it is, right? So it's like, now the log messages don't quite look correct, but all my code is saying that I'm doing things right, so what the hell? So... Let's say 22. Okay, so let's explain what's going on here in this formula down there. So first of all, we have to do a 0 because the add to value, if we're zooming in with a positive value, we actually make the rectangle smaller, right? So this add to value needs to be a minus because of how this interface, the contract for this function works. 384, yeah. I'll go through that again. If you could have any insights, I have no clue what's going wrong. So the zoom value needs to be inverted here because a positive value means to zoom in, right? But to zoom in means to make the rectangle smaller, right? So if this is always an additive value, well, everything is topsy-turvy, right? I don't know if I'm explaining this right. But zoom camera, if you give a positive value to zoom camera, it subtracts from the rectangle, right? And if you give a negative value to zoom camera, it adds to the rectangle. And the reason for that is because I'm thinking in terms of zoom camera, I'm thinking of a positive as zooming in, and then a negative as zooming out. And I don't know if I regret that or not. I'm starting to regret that. Because it's not the way the math actually works. But when you think of a positive zoom, you think that you're thinking of zooming in, right? Right? 4x, 3x zooms or whatever, even though this is not a zoom factor, so it's not even that anyways. And then if you think of zooming out, you think, well, the opposite of a positive zoom would be a negative zoom, right? Or technically it would be like a fractional zoom factor. So I don't know. I don't know if I like the way I did this. But that's the way it is for now. I think the convention from an API standpoint makes sense, right? Positive to zoom in, negative to zoom out. From a usage standpoint, it makes sense, but from like a math sense, it doesn't make sense. So that's why we have this negative here, right? Then also, if you give zoom camera a 1, it's going to either pull or push each edge of the rectangle by 1. So effectively growing or shrinking the rectangle by 2. And so since this is the vector we're going to use to go from the old span to the new span, we actually have to divide that by 2. Because an input of 1 into this function would grow the rectangle. Input of 1 would shrink the rectangle by 2. And then an input of negative 1 would grow the rectangle by 2. So we have to divide this by 2 to counteract that behavior of this function. And so we are actually seeing what we expect to see, but for whatever reason, the logging function doesn't actually look correct. So if we have to look at the logging function, so go 1, P for pattern, load a pattern in here, and let's take the top level pattern. So when we zoom in here, these numbers make sense, except for that negative that kind of pops up sometimes. Like it's working, but then sometimes we see an add to next is like a negative. Oh, that kind of makes sense. I know why that would. So I have no clue why. Oh, sometimes we get it to say 256. It's almost like 320 and 64. I have no clue. But I can verify that this is pretty much behaving as I want it to. It seems pretty much correct in terms of the behavior. It's obvious here, because we have the 1 pixel zooms out here. Here, if we want to confirm the zoom is working, we can manually try to zoom in and out, right? We can do 1 pixel by 1 pixel, and if we try to zoom out, if we try to snap all the way to here and zoom out further, we can't go any further with the keyboard shortcuts. So even though it's reporting 320, the span we're getting out is 256, right? So I have no clue why that is. And I don't know if this is something I don't know if I want to leave this mystery broken, though. Well, okay, 320. And we're going to... Oh, wait, 320 minus 64. What happens there? $256. Hello. How's it going? What's up?
Well, I need food.
See my zoom? Oh,
Yeah.
hold on. Let me stop it. It crashed. It crashes. The window crashed. Okay, so I figured... Okay, so let's go over here.
Are you streaming?
Yeah, I'm doing the streams. Okay, so...
Take a break.
Okay, I take a break. But first, we have to do this. And then I can... Okay, so we load the pattern, right? And then we go all the way up here to this pattern here, right? And here's my shortcuts for zooming in and out. So, hold on. R? No. So see this right here, zooming in. We're zooming in, we're zooming in by 1 pixel at a time.
Yeah.
So you see this is like, this is 2 by 2, right? And then we zoom out, and instead of 2 by 2, we add a pixel on each edge, right? And then we zoom out, add another pixel on each edge, right? Zoom out, add another pixel on each edge. So the zoom speed here is linear, right? So it might look like out here it's going very slowly, right? This is painstakingly slow. And then once we get in here, it starts to look like it's going really fast. Like this looks...
I get it, yeah.
You get that idea? So that's just the result of perspective, right? But it's not very good for an editor, right? Like, if I want to zoom all the way in really quick, I don't want to, like, wait like this, right? So, to make the zoom seem more linear, even though this is a linear zoom, to make it seem more linear from an observation standpoint, we have to zoom in to a more extreme degree when we're out here, and then zoom in less extreme when we're in here. So the mouse actually does that, right? So I made the mouse so that...
Oh, I like that, yeah.
So the mouse has the nice punchiness, and I can get all the way in there if I want. And then if we need to do some fine-grained zooming after we've punched in there, we can use these shortcut keys. And then also IJK, kind of like, ooh, moves around here. Okay. So the next thing I want to do is make it so that I can click and drag.
Yeah.
And also the pixel setting actually kind of almost works all the way. Even when I'm zoomed in and translated, it's working, but there's some other things I have to work out here. But yeah, so that's the basic thing, and it's doing pretty good there. So anyways, let's see. I figured out what I wanted to figure out. So let's just assume that it works, because that 64, when we use 64 as a minus, and we can see right here, minusing, the behavior is correct, the math works out when we crunch the numbers with the negative. So I'm going to assume that it's correct. So we're going to do get status, we're going to add all this stuff, and back up our work. And then, I don't know, I'm doing something, I guess. Get status. Get commit-am. Mouse zoom finished, right? So the mouse zoom is finished. And get status, okay, git push GitHub master, and then we're also going to push this up to Kanji Coder since it is, it's in a working state, right? It's not crashing on compile. There's no runtime assertions that are failing. So it's good enough to push up to the public. So we're going to push it up to Kanji Coder as well, so you can take a look at that if you want to take a look at it. Alright, so with that, I'm going to get out of here, and I'll see you when I see you. Okay. And then we stop the stream.